Welcome back, students. This is the session 13 from the chapter of circular motion. The topic is forces in the circular motion. So this is going to be a very small session in which I will be discussing about the types of forces which are encountered in a circular motion. So here I have drawn one diagram here, and here this is the position of an object at any moment of time. It is moving in a circular path of, say, radius r. This is the radius of the circular path, and O is the center of this circular path. So at any moment of time, if this object is moving in a circle or in a circular path, then at any moment of time, or you can say at any point on this circular path, it will be subjected to two forces. That is, one is the centrifugal force and second one is the centripetal force. So here I have made one diagram here in which I have shown the direction of the centrifugal force and the centripetal force. A body which is moving in a circular path will be subjected to a centrifugal force which is directed radially outward, as shown in this figure. Here I have made one tangent here. This is a tangent at this point. So the direction of the centrifugal force is directed outward, and the angle made by this centrifugal force with this tangent is 90 degree. So centrifugal force is directed radially outward, and the centripetal force is directed radially inward. That is, it is making an angle of 90 degree with this tangent. So now when centrifugal force when centrifugal force is equal to the centripetal force, then the body moves in a circular path, as it is shown in this diagram. Now the magnitude of the centrifugal force is equal to mv square by r, and so the centripetal force has to be equal to this centrifugal force, so that this body moves in a circular path. So it means that the centripetal force should be equal to mv square by r. Now we also know that v is equal to r omega, so this can be written as m r square omega square upon r, or it can be written as m r omega square, and this can also be written as since omega is equal to 2 pi upon t, so m r omega square, this is 2 pi whole square, and this will be equal to t square. T is a time period, that is, it is a time taken to complete one revolution. So centripetal force can also be written as m r 4 pi square divided by t square, and this can also be I was just writing it here, the centripetal force is equal to mr 4 pi square upon t square, where t is the time period of this motion. Now the most important thing here is, if the body is moving in a circular path, then the centripetal force should be directed radially inward. Means radially inward means that this centripetal force will be directed towards the center of this circular path. So the centripetal force should be directed radially inwards, that is towards the center as shown in this figure, and this should be equal to the centrifugal force which is directed radially outward. So in this case, whenever a object is moving in a circular path, for example, I have this one string here. Now, if I am just rotating like this in a circular motion, then in this case, the centripetal force will be provided by the tension in the string. So centripetal force is basically, it is provided in different ways. That is, if for example, if you are rotating some object with the help of a string, then that tension in the string will be providing this necessary centripetal force. Similarly, if you are moving in a circular path on a surface, or you can say on a road, then in that case the centripetal force will be provided by this force of friction. So centripetal force can be provided in different ways. It depends on the type of the motion, and this has to be equal to the centrifugal force if this object is to move in a circular path. So just for the sake of understanding this concept, I'm just writing it here that centripetal force can be provided in different ways. That is, as I just stated here, that such as in rotating a body with the help of a string, the centripetal force will be provided by the tension in the string. Tension in the string, and that tension will be directed inwards towards the center of that circular path. So this is one type of this is one example which I have just told you. However, for example, if you are moving on a you can say on a road, okay? So in that case, and if you are moving in a circular path on a road, that in that case, the this centripetal force will be provided by the force of friction, and that force of friction will also be directed towards the center of that circular path. So so a body moves in a circular path when the centripetal force is equal to centrifugal force, and this is the equation for the centrifugal force and the centripetal force. And yes, one more thing here, this mr 4 pi square. Now you know that the frequency of revolution is given by, that is, f is equal to 1 by t. So this can also be written as f, this f square, where f is the frequency of revolution. What is frequency of revolution? It is the number of revolutions performed in 1 second. So F is equal to 1 by T. So I have substituted the value of this F as in this equation. So this centripetal force is also equal to mr 4 pi square F square. So thank you very much for joining this session, and in the next session I will be coming up with the derivation of the centripetal force. So till then, have a nice day. Bye.